Hello everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about complex integration. Definition of complex number. Complex numbers are the numbers that extend the concept of real numbers by introducing the imaginary unit I, defined as I square equal to minus 1. A complex number is typically expressed in the form of a plus ib, where a and b are real numbers and I represents the imaginary unit. Polar and exponential forms of complex numbers. Complex numbers can be represented in multiple forms, two of which are the polar form and the exponential form. Polar form. In the polar form, complex number z represented using its magnitude r and argument theta. The polar form of a complex number z is given by z equal to r into cos theta plus I sin theta. Exponential form. In the exponential form, a complex number z is represented using its magnitude r and argument theta as exponent of the base e. The exponential form of a complex number z is given by z equal to r into e power I theta. Limits and continuity of complex functions. Limits of complex functions. Just like in real analysis, the limits of a complex function f of z as z approaches a complex number z0 is the value that f of z approaches as z gets arbitrarily close to z0. Formally, we say that the limit of f of z as z approaches z0 is L, denoted as limit z tends to z0 f of z equal to L. Continuity of a complex function. A complex function f of z is said to be continuous at a point z0 if the limit of f of z as z approaches z0 exists and is equal to f of z0. Properties. Complex function can exhibit behaviors such as oscillations, convergence to a point, or divergence as a z approaches certain points or along certain paths in the complex plane. Differentiation of complex functions. Complex differentiability. A complex function f of z is said to be differentiable at a point z equal to z0 if the limit of the difference quotient exists or as z approaches z0. Formally, f of z is differentiable at z0 if the limit f dash of z0 equal to limit z tends to z0 f of z minus f of z0 divided by z minus z0. Integration of a complex function. Line integral. A line integral of a complex function f of z along a curve C is denoted by closed integral f of z dz. The integral represents the sum of f of z along the curve C, where dz represents an displacement along the curve. Cauchy's integral theorem. Cauchy's integral theorem states that if f of z is analytic within and on a simple closed contour C, then the integral of f of z around C is 0. That is, closed integral C f of z dz equal to 0. Next, Cauchy's integral formula. Cauchy's integral formula provides a powerful method for evaluating integrals of analytic functions over a closed contour. That is, f of z0 equal to 1 divided by 2 pi into closed integral f of z divided by z minus z0 dz. Cauchy's integral theorem and formula. Cauchy's integral theorem states that if f of z is analytic within and on a simply connected region D bounded by a simple closed contour C, then the contour integral of f of z around C is 0. That is, closed integral C f of z dz equal to 0. In simple terms, if a function is analytic in a region D containing a closed curve C, then the integral that the function around C is 0. Next, Cauchy's integral formula. Let f of z is analytic inside and on a simply connected region D bounded by a simple closed contour C. Let z0 be a point inside D. Then for any z0 inside C, the value of f of z0 is given by f of z0 equal to 1 divided by 2 pi I closed integral f of z divided by z minus z0 dz. Applications of complex integration. Complex integration has a wide range of applications across various fields, including mathematics, physics, engineering, and finance. In physics, complex integration used in electromagnetism, quantum mechanics, and fluid dynamics. In engineering, complex integration used in control theory, signal processing, and electrical engineering. In mathematics, we use complex integration in complex analysis and special functions. In finance, complex integration is used in option pricing, stochastic process, etc. Overall, complex integral provides a powerful mathematical tool for solving wide range of problems. Thank you.